Sweet. Right. Hello, everyone. I'm Tiġearnán. I'm a senior engineer here at Teamwork. My talk is about BDD testing in Golang. So, what is BDD? It's an extension of test-driven development. I know we're all sick of hearing about it there, but it emphasizes feature development around user stories. I'm assuming, for the most part, all of us here use and know what user stories are. What is cucumber testing? It's a test process written in the Gherkin format, which expresses tests in natural language as opposed to code. So having tests written in natural language actually brings us a few advantages. It enables our non-technical members of an organization to understand and potentially contribute to test suites, assuming your definitions are that good. It enables developers who are less familiar or experienced, like juniors, to understand and contribute to test suites far more readily. And making the tests themselves become firm and unambiguous acceptance requirements. And finally, writing tests in a natural language forces us to make like good abstractions, because bad abstractions stick out like a sore thumb, because we all speak naturally every day. If something reads funny, we're gonna know. Gherkin provides us a series of keywords given some precondition, and usually takes on the form of like the previous keyword that we used. So in this case, and would provide another precondition. When I do an action, so this is like the actual test that you're doing. So when I make this API request or when I stage this event, then is where you assert your results. So then some result should be met and some other result should be met. So an example of this is like given I state the database with some test data and I log in as an admin. When I send the GET request to my contacts, the response code should be status okay, and the response body should match some source of truth.json. This is just a wee JSON file that can be in your file system with the exact API response you would expect, lay it out there. So a Cucumber test suite has three main entities around this Gherkin format. So they come with steps. A step is a single instruction written in natural language. In terms of the Golang translation, they'd be akin to a well-defined function in an integration test suite, such as suite.create user with a DB connection or something that will go and create that user. So given I log in as an admin as an example, and then the response body should match account created.json. Scenarios are a collection of steps structured to test some functionality or test case. So a scenarios are given a description declaring like what exactly they're testing. Think of a scenario as a test function in your test suite. So something like test account underscore create with a test and T header or something. Like a test function, they're designed to be independent and do not rely on any other scenario to mutate that state, and they should be able to be executed concurrently, but that's always a pipe dream we have for test suites. Like the second you bring IDs into it, you're how do I do this? Like so an example of a scenario here is kind of cool. So I run the SQL, reset SQL, and then I provide the headers. So provide the auth as a header. Given I make a post request to this account endpoint with this JSON file on my file system as a body, the response should be created and the response should match the expected response back. Finally, feature files is the feature being tested. So features give a description of what should be tested, and they can also declare rules/criteria for the documentation purposes. They're akin to your actual _test.go file in your integration test suite. So an example, like we have this feature of like account creation, we've got the rules, we got an account successfully created, just all the predefined criteria that you would expect this to meet. Yeah. So putting all this together, we end up with a file that's quite nicely written, like so. Quite easy to read. You go in and you know exactly what the fuck's going on here. Like so. Yeah. But where does Go come into this? Like obviously we can't just like point like Go test at these feature files. Like we need to somehow link our English to a framework provided, preferably by the Cucumber group. But luckily we have just that, GoDog, the wee boy that he is there. So there are two ways to bake GoDog into your test suite. You can either use testing.t or testing.m. Both of these come with the advantages and trade-offs. So testing.t, if you use it that their way, you get the advantage of you can start using the Go test tooling API. So Go test like -run and then do regex matching on your scenario names. But you have to set up the suite for every single test case that you have, which is a bit cumbersome. So for the purposes of this, we're going to use testing.m because like in my opinion, it's far easier for integration testing. And so whenever you use testing.m, you end up going whole hog in on the GoDog API for interfacing with it. But the GoDog API is pretty good, so it's not that much of a trade-off. Yeah. So imagine, just for like a quick test case of this, imagine we have some like account entity and we want to test its ability to withdraw money. When funds are withdrawn, the balance is updated to reflect this withdrawal. If the funds requested exceed that balance, the balance isn't touched, and instead we just relay an error to the user being like, you're withdrawing too much here. The unit test in Go would look something like this, nothing too crazy. We've got some testing map with balance and withdraw amounts, and then the expected state. We have the names of the tests as the key to the map, and then just we have our test case here, the assertion. The same test in GoDog in Cucumber would be written like so, which I'm pretty sure we can agree like it's much easier to read. So let's get to wiring this up. So to begin, we create our test main function and build our test suite struct. So you provide this GoDog.options thing. This is provided at a global level so that we can actually start overriding these with command line args, because then we pass it in down here. I haven't shown that in this slide, but it's there and it's possible. So with your test main, you define it and then you execute it with os.run. We also provide this scenario initializer to the test suite. Get into that now. Inside the scenario initializer, we go and we map all of our natural language steps to the corresponding Golang function. So in this scenario, you get your context, SC stop. I have an account with, X amount of money. You map it then to this I have an account with function. I withdraw this amount, you map it to this withdraw function. Important to note here, this regex match with the captured grip, that will come into play shortly. Whatever you put in your regex group and matches, they're provided to the function that you provide here as parameters. So if we go on, you can also in this init scenario function define like certain hooks. So you've got before step, you've got after step, before scenario and after scenario. This before step, we're just doing like a time sleep for 500 milliseconds just for, you'll see later on, like you wouldn't actually do this. Like we actually want you to see these tests getting executed one step at a time. So yeah, step functions. So this is where it gets a bit wordy. Like, so step functions can take a context as their first argument, because like if we actually go back to this slide here, where are we have all this, we have the account here that actually persists throughout, like goes like this is a step, this is a step, this is a step. We have this account entity that we have in scope throughout the entire test itself. But here we don't actually like where is the account, where is the entity? Well, you can use context.context as the first parameter, and if that is there, GoDog will notice this and build a context for your scenario and provide that there to every single step. So then, so for like with, I have an account with, we then just define return context with value with this new account. If you return the context.context, GoDog will then take that new one and then provide that there to the following step. So you do have a complete scenario step-by-step context. The same for withdraw. You can just lift the account straight out of the context, pull withdraw, and then drop it right back in, or drop the error right back in, sorry. Then same with these steps here. an error should state, we lift the error out of the context. If it's nil, here we were expecting an error, will fail. If it doesn't have the same message, we were expecting this particular error, otherwise return nil. If you return an error in a step, Godog assumes rightfully that is a failure and hards out of the test case. So we now have a test suite that we can run. So I can show you this executing here, step by step. Every single one of these steps is executing the Golang under the hood, passing the context through, doing the update, and then we're done. And you can see that's why the time.sleep is there for the 500 milliseconds, because if that's not there, this runs like lightning. So yep. Any questions so far? Yeah.
So context generally type.
I done it generically here. You can either do a type assertion, because like it's your test scenario. You know what's going in. This isn't like some customer data. You control very stringently the data going in and out. So if the context ever fails your type assertion, that's actually a sign that your test has went completely wrong anyway. So it should fail. You do want that catastrophic error in that case. That is? Sweet. So run the subset of tests. So since we no longer have like the go test -run flag anymore, like sometimes you just want to test either a new feature you're doing or some, like you've just modified some feature and you want to run the entire test suite and that feature alone first because your tests are quite expensive to run. Since we're using testing.m, we don't have access to that, but luckily Godog exposes a really nice way to run a subset of tests. So let's say we added some new deposit functionality to this account service and we only want to run these deposit tests. What we can actually do is we can tag our tests like so. So we've tagged this one account withdraw, account withdraw error, account deposit error. And obviously the deposit ones are linked to the new deposit steps and the withdrawal ones are still linked to the old withdraw test cases. We can selectively run these with the godog-tags flag. So if I pass in --godog.tags equals deposit, you will see it will only execute the deposit tests based on the scenario name. We can change this then to withdraw. We're going to get the withdraw ones. We can even whittle it down. So you might have noticed the error ones. So we can run the two, the withdraw and the deposit error scenario. But you can actually like use conditional logic in this. So I could do like deposit and error. And then that will only run test cases that match both of those tags. In this case, that one particular one. So they can also be randomized with godog.random. This obviously helps ensure that our tests are written correctly and their state is independent and helps find random state bugs. So execute again, hopefully we'll get a good shuffle. We get the withdrawn, withdraw, deposit, and withdraw. But what it also does, it gives you then the seed back that you use to randomize it. So you can actually pass this back in and then run the exact same scenarios. So if your test suite ever did trip up in a particular random order, you can reliably reproduce that. Concurrency. There's a slide bug there. Ignore that there. So concurrency. Oops. We can run our tests concurrently with the godog.concurrency flag. So in the previous examples, these were obviously taken.
Yep.
So in the previous examples, these were taken, as you can see here, 7 seconds to run because of that darn time.sleep. We can, if we pass in concurrency.4, you'll see they absolutely just dominate through it. You get 2 seconds done. It's all cool. However, that's actually pretty unreadable if you run it concurrently. So you can actually change the format as well. So format is progress. And then you'll get them running concurrently as dots. 1 dot equals 1 step. So you can keep your output nice and pretty. While if you manage to crack the challenge that is concurrent testing, there you go. So that's cool. But like that doesn't even begin to tell us like how to do this for integration testing. So yeah, how do we do that there? So some of the hallmarks like basic integration testing is like you've got a direct database connection to prime your data. You have some like HTTP or gRPC client that's tailored towards your service that you're testing usually to perform your requests. And the test data you have, it's usually in the form of like some struct or some files in the file system that you load in and then load that data from into some in-memory object. So let's get the wiring this up. First thing you need is some like, well, there's many ways of doing this. This is the way I do it. You have some like global suite struct that has all the information you need. So you got your URL, like the base URL that you're going to test. You have your GoDog test suite because I guess it's handy to have that knocking about. You have your database connection. You have data stores. This is an abstraction I'll explain it in a second, but it's pointing to like your SQL files and your HTTP requests and responses, and then you have a HTTP client. The data store is just a wrapper around FS embed that allows us to like provide a prefix, so we don't actually have to worry about where the file is in the file system. We can just go, oh, like I'm doing a HTTP request with post data or something, and then these embeds are just go embed for your HTTP and SQL data. We then wire this suite up, so we get our database connection. Obviously, handle that error, but I'll just ignore it for now. This can be configurable with command line args just for simplicity of this test. You want to add. We define the data there with SQL data and have its SQL prefix, so that then if we go back to here, the prefix is actually joined on, so we only care about the file name itself. It shouldn't really care where your data lives. You then define your all the rest of the stuff, all this yourself. But the one thing we change here is that the scenario initializer is defined outside of the struct declaration because we actually want the suite as a receiver func. You go on to your net scenario, you'll notice as well the suite is still the receiver func here for all of our scenario, like all of our steps, and that's because we want the individual steps themselves to have access to that all that database and HTTP client goodness under the hood. And then these are some example steps you can do, the ones I had earlier. So given I run the SQL, given I run the headers, given I make X request to Y, whatever, whatever. So running the database connection in this way. So given I run init.data.sql, here's what it looks like under the hood. You've got I run the SQL file function even, takes context because we're going to give that there to the database connection. You load your SQL data and you just run it and then store or return the error if it exists. Simple as. So you never have to care about this again, and all your tests is just I run this SQL. Given the headers, again, simple as. You create a header. You try and get the current headers from context in case you set them later on. If it's nil, you create the new one. You go and set the headers, then you store that in context and return it back out. Simple as. And again, actually, what you should talk about here is the table notion. Sorry. So GoDog lets you, or Cucumber itself lets you define like iterative list data in this table format. It's typically good form to title what the data is, and then you can just iterate it. So you get this table thing, then you just iterate its rows, and then you just chop off the header, obviously. And then you get the key and the value, and then store it, whatever. These can be as long, like as wide and as long as you want them to be. The HTTP request. So given I make a post request to my endpoint with my request.json, big one, but again, it's absolutely fine. So this one should handle both cases. If the file isn't empty, then we actually load it into a reader. Otherwise, we just pass it in as nil. That's absolutely fine. And then you just do the HTTP request, read the bytes, entirely your choice if you want to do that there, obviously. Then you store the response code and the bytes in the context as well, and then return that there out. Then checking the response code, simple as we have this incomplete map. Because obviously I think there's a few more HTTP response codes than that. So yeah, again, error if we don't get what we want, and then the response body should match. So we here, what I typically do is we load the response body from the context. We'll lift the expected body from the file that's being passed in. Then we just marshal these in as JSON into two just empty interfaces. And then there's this lovely tool called diff, because these come out as maps. So you can just pass both the maps in. It'll run a differential on them, and then it returns your report. If the diff is identical, we return nil. Otherwise, we actually return a differential report, and it actually tells you exactly like what is different, the exact like line in the JSON response. It's quite nice. So yeah, so this is going to be a quick walkthrough of the file structure here that you'd expect of your integration test suite. So if I run, so it's actually should be here. So I've got just my simple wee API server, API, it's got the service layer, the database connection, all that doesn't really matter. But if we tree the test directory, so we have our integration test file, which is the one that instantiates the suite. We have our data dir, which is just that there we data loader abstraction. We have our features. So this is where all our feature files live. There can be multiple in here. There could be like, Fanny or whatever. These can also be in subdirectories. GoDog will find them and run them. It's absolutely fine. You've got your HTTP directory with all your requests, partitioned by partitioned by, you've got your responses, and then you've got like errors, which can be general errors that are just going to be thrown without any information, and then SQL. So we can actually give a quick run of this too. So I'll go test. So we're going to run this for like an actual integration test suite. For that scenario was shown earlier. Shall I do it by progress? Like so, and then that goes and runs the entire thing. So that there was doing full database connections, plan authentication, and making sure all the data was running correct. Any questions so far, Nat? Before I will do a show. We'll modify one of these files after the fact to show you what it looks like in an error case. I just haven't done that there. So yeah. So what else is possible here? So HTTP and DB connections are cool and all, but we actually can't take this much further. So just for examples, a couple of ones I've done myself, like S3 action. So given I put files into buckets, you bucket your file into this bucket. I want file.txt, into this other bucket I want holyhell.jpg. And then this is just the signature for that. So obviously you iterate your table. You have your S3 client loaded, obviously in that their suite at the start. You put the object, and then just iterate them and then just drop them in. The test data is obviously another FS embed or embed FS. And again, you never have to care about this. It's just this line of English. The same with deleting files. So this is a wee bit more complex. You just have to, at least my use of the AWS API, you have to list them first and then pass in, then get matching objects and then pass the actual object into the API. Same thing. RabbitMQ funds. This is where it kind of gets nice, because like I've seen code bases before that like they do something that causes an event, and then they do like a time.sleep to hopefully wait for that event to end. With this, you can actually get quite a nice abstraction to like subscribe to the queue locally and wait to actually receive that event yourself and then ply on. This is kind of like this won't work code because it's like a lot of internal stuff, so I couldn't really show it. But like, this is like my best way to try and showcase it. So up front, we tell the suite like what queues on what exchanges we actually wanted to subscribe to. So let's say we have this accounts exchange, and then every time a bank account is created, it'll just fire it off in this, and then we want to do something with that there. We then would build a map of exchanges to queues. So because obviously we can provide multiple of these, so we can have like another accounts exchange with bank account deleted, and then it would just be one entry in this map. And then for every written key in this exchange, so because like this is a list of strings because we can provide loads, we then store in like a synchronous map. For every written key in this exchange, we or queue even, we would create a new queue group. So for this accounts exchange, we will have this entity that can receive data from all of these queues via the means of channels. We store them in an asynchronous map. And then within the queue group, we actually go and store the store the channels matched with the queue. So this lets us go on this accounts exchange and on this queue on that exchange, I want this data. And then you can just receive it with this VC thing, and that just returns a read-only version of the MQP channel. So with this abstraction, what you can actually write in your code is, when I wait for a message on the accounts exchange bank account created, and then that your code will actually block if that queue is empty, if it's a long running job, And then the implementation of that is just, you'd obviously give yourself a wee timeout, so your test doesn't run indefinitely. Whatever comes first, the timeout or the message itself. And yeah, you then store the message in context in case you want to like assess its body or assess headers or something. Then you know you can do, yeah, this is cool too. I quite like it. You can actually check like length check. So if you're like having some like event that like it's going to send progress updates at like deterministic times, and you want to make sure those progress updates are sent, it's just as simple as like a length check on that queue, because you're going to have like it's buffered to whatever ends, like, so it's just no API request needed. And yeah, that's it. So I'm currently working on open source in the library that provides like a lot of this functionality out of the box. It does a fair bit more, like there's templating for like responses and stuff you can get into. But yeah, hopefully if you do this presentation, we'll have a working example of that there. Yeah, so that's a wrap. GitHub is Thai Latte, and well, yeah, that's me. If there's any questions or.
And then when you use regression tests, could you use a separate suite of like regression tests?
Yeah, whatever way you can think. If you can like whittle it down, like if you can get good English defined for what you want to do, like the sky's the limit. Like you just pick it up whatever way you want. We'll see. I'll try and get there's unauthorized. Is it? Yeah. I'm trying to show you what it looks like if it fails. So if I like change the status code or something really simple, and then I go to test. Yeah, so the error is kind of massive, but it's all right. It actually gets kind of nice. It literally tells you exactly, oh, I wanted 401, I got 402 for the way def thing. It's a lovely way of doing it. So yeah, that's
it'd be cool to show people the different files you set up, you know, JSON files.
Oh yeah, sure, that'll do. Yeah, so yeah, so within test we have, so SQL, it's literally just like raw SQL. Like that's like we just write our SQL files and then we pass that in. And the request, you know, here's the request. Data, that's just my Go code, you know. Then the feature file is just the feature file that is shown at the very start. It's all just very much like, see, it's kind of cool as well, because like the implementation of this is Go, but like the actual writing of the tests, you don't actually write a line of Go if it's done really well. So your company could realistically, I've never seen this, it's like, but it could realistically define like a really, like, this is our set template of tests, what we want. If you're going to write an integration test suite in Cucumber, this is how we want it done. And then you could actually jump about write integration tests for different language code bases, because you're not actually interfacing with that language, you're just writing files. So that well, I write these in the way that every single bug ends up as a test in these do, with all the steps which aren't product defined user stories. But like the way I would love to work personally, intent like, is that product could actually like just write even at the top this wee rules definition for different aspects of the feature within this file. And then maybe I wouldn't expect this, but maybe scenario headers. And then we could actually go and then implement this or have something to work towards. I wouldn't expect them to write the scenarios, because like I run the SQL.
So it is the sort of thing that like other places I work where it's like you do some business stuff like technical PA. People that
Oh,
this is like absolutely anyone working anywhere with technical PA, like something like that.
Yeah. Actually,
Yeah.
Oh, must have been a good spot.
You wouldn't do something like this, particularly like that people like SQL or I'd be surprised. The scenario thing that was like,
How did this perform in a CI/CD environment? Did it perform well?
Yeah, so because this is done with like OS embeds, you can actually well, let's see if we can. You can actually just run go test.c and compile it into a binary, and then you just run it. Oh well, it has to be in the right directory to do it. Like
you can use like some Docker compose or
Helm or whatever to set up your every test environment and your CI/CD pipeline.
Yeah.
Run the test against it.
Yeah.
And then
Well,
especially with Steam.
didn't want to open a battery. There's unauthorized. Yeah, so like in one of our internal integration test suites, like we set up this like Minikube cluster locally and then bring up our product in it. And then we compile the integration test suite into a binary and deploy it as a container. So it's like running as like an internal network as the user. And then like it is just, I don't know why it's feeling like, but yeah, it is just like run that like if you get your embedding done correctly.
Yeah, you definitely.
I didn't see that.
Into your CI/CD pipeline for sure, yeah. That's a little bit hard, the longest part's just setting up your environment sometimes, but if it's done right, then it can be pretty quick.
Yeah.
I set up one fairly recently on using Helm and Kubernetes, with the namespace
Yeah, yeah.
Kubernetes environment.
Yeah, so it's like it's absolutely like it's as quick as like your API tests and data, like and your API requests and SQL queries would be. It's absolutely fine in that regard. Godot comes like quite like little underhead, like you know, theirs is making a series of like API requests at like 32 milliseconds, like, and that's like with me like putting this slideshow together with a few beers and all, like there was no smarts behind this, like so like it's like the one problem with this I've found is that it is so easy to write tests. You end up writing like more unit tests than is needed. So you do get a bit of like, you know, testing is meant to be cone shaped, but you can't get quite top heavy with it. Like, so if as long as you can put a bit of restraint or maybe tag some of the tests as like, you know, critical happy path or something like the core functionality you want to run on your CI/CD, like that's up to you.
What's nice about this is using the files, so you don't need to like hard put in, you know, if say you're using structs and things, you have to like a step for each individual struct you're using because you're passing those JSON files and
Yeah.
keep it really generic.
Yeah. It's nice.